In our previous nugget on load balancing using DNS policies, we learned about the basics and ingredients that go into a policy, including creating scopes, having records in those scopes, and then creating and applying a policy that uses those scopes. Well, to reinforce the concept of policies in DNS, let's go ahead and set up a policy that's going to control how the DNS server responds based on the source IP address of the client that's making the request. For example, let's imagine we have a couple different subnets of where clients live, IP subnet 1 and IPv4 subnet 2. And what we could do with the DNS policy is tell the server, okay, take a look at where the request is coming from. If it's coming from subnet 1, then go ahead and feed out the answer out of scope 1, for example. Or if the client happens to be coming from a different source network, for example, coming from subnet 2 as a source IP address for their DNS request, go ahead and give them an answer out of scope 2. So what we'll do is we'll create a brand new zone just for the purpose of the demonstration. We'll create a couple of scopes in that zone. We'll create records with the same name but a different IP address. And then we'll go ahead and apply those policies. It'll actually be two policies, one for traffic coming in from subnet 1 and another policy for traffic coming in from subnet 2. For our hands-on lab, we're going to start here on the Windows 10 client. Now I've got in the file system for this lab, I've got the syntax that we can use. And the reason I have it there is, number one, it's a lot of text. And secondly, it can be a great reference if you want to peek at it and look at it as you manually put the commands in yourself. So to find it, let's go ahead and click on the Explorer icon for File Explorer in the taskbar. Let's open up the temp folder. And here in this temp folder is the 18-HMM server file. It has the extension for a PowerShell script, but we're not going to run it. I just want to open it so we can talk about all the commands, and then we'll go ahead and walk through putting them in. So for now, we're going to just right-click on 18-HMM server, and then from the drop-down, we're going to click on Open With, and we are going to select Notepad. I want to open that with Notepad just so we can see the contents. So with Notepad selected or highlighted, we'll go ahead and click on OK. And I'm going to maximize that to full screen. At the beginning of this, I have a command just as a reminder of ways that we can get help with our PowerShell commands. So get-command space -module, DNS server, and then -name, asterisk policy asterisk. That'll give us all the DNS server related commands that have the word policy in them. And all the server commands that we're going to need for this nugget are right here. So our first command is going to be this one right here, add-DNS server primary zone. We've seen this before. We're going to create a new zone called .com. And that's because we can kind of envision the server, the DNS server, when it gets a DNS request going, what should I do? Because we're going to set up some policies to make it respond differently based on the source IP address of where that request came from. So we create a new zone called .com, and then we identify a couple of client subnets with the add-DNS server client subnet command. Let's name one of them 64_subnet and the other one 128_subnet. And then we're going to use the -IPv4 subnet and identify what those subnets are. Now, if you're not yet a master with IPv4 subnetting and the various blocks of addresses that can be used in a subnet, no worries. If you want to get better at that, we have a course dedicated to that with IPv4 subnetting right here at CBT Nuggets. You can go check that out at your leisure if you want to get better at it. But for now, I just want to point out that these two networks, 192.168.1.64 and 192.168.1.128, both with a 26-bit mask, from a network perspective are different networks. It's like network A and network B, or we could refer to them as subnet 64 and subnet 128. In a network environment where we are not doing any custom subnetting, we might have, for example, 192.168.1 as one network and 192.168.2 as a different network, both with a more traditional 24-bit mask for each of those Class C networks. And let me tell you why I did the custom subnetting for this demonstration. It's because we are going to change the IP address for our Windows 10 client. If we change the address for our Windows 10 client, or any client, if the first three octets are 192.168.1 for either one of these networks, but the last octet, the last number, is 65 through 126, it's going to be in network A or network 64. If the last octet is 129 through 190, then from a networking perspective with IP addressing, that client is on the 128 subnet. And that way, if we set up a policy to make a different response from the DNS server based on what subnet we're coming from, we can just change our Windows 10 client to be in either of these ranges to put them in the network that we want them in. That's kind of a long explanation for why I carved up the subnets, but I wanted you to know. And have no fear, if you're not that good at subnetting yet, just realize that the 64 subnet and 128 subnet with this mask are considered two different logical networks in the world of IPv4. So what we're going to do is we are going to identify both of those DNS server client subnets by these names, And then we are going to create two scopes. We're going to create one scope called 64_scope and another scope called 128_scope. And they're both scopes that are going to be in the zone called HMM.com. And then we're going to add an A record to each of those scopes. They'll both be called SRV-XYZ. They're both going to be in the HMM.com domain, but they're going to be in different scopes. We're going to put one of those in the 64_scope and the other one in the 128 scope. So whenever the server responds, if it responds from the 64 scope, it's going to go ahead and give us the IP address of 22, etc. And if it responds from the 128 scope, it's going to go ahead and give us the IP address of 33, etc. regarding that host name that's being resolved. So once we've identified the subnets, we've identified the scopes in the zone, and we have at least one A record in each one, we can then go ahead and create our policies, plural. There's two of them. The first policy is going to be called 64_policy, and the other one's going to be called 128_policy. On the 64_ policy, it's matching on the 64_ subnet. And for the 128_ policy, it's going to be matching on the 128_ subnet. And what I did was I integrated the names of each of these objects regarding their function. So up here for the subnets, I include the word subnet. In the scopes, I include the word scope. And in the policies, I include the word policy. That way, when you look at the config and you're walking through it, stepping through it, from a learning perspective, it's a lot more easier to remember and actually visually see where those pieces go. So regarding these two policies, looking for source addresses from either of those subnets, the results are, if it matches 64 policy, it's going to go ahead and use the scope of 64 scope. And if the source address of the request equals the 128 policy, which is matching on the 128 subnet, it's going to pull the record from the 128 scope. And these policies are both being applied to the zone HMM.com. So let's go ahead and close Notepad. And I'm going to minimize this file explorer in case we need to come back to it. And what I want to do is let's open up the PowerShell scripting environment, but this time, instead of just clicking on it in the taskbar, let's right-click on it. And then from the menu that pops up, let's right-click on the Windows PowerShell ISE. So that's two right clicks, and then we're going to go ahead and select Run as Administrator. And we'll go ahead and left-click that. And then we'll go ahead and click on Yes for the user account control. And the reason we're going to do that is because I've got a couple of commands to change the IP address where we need elevated privileges to go ahead and run it. So up here on the top, it indicates that we are running this as administrator, which is fantastic. And let's go ahead and bring in the PowerShell script that we just looked at. To do that, let's do a Control-Shift-R. To bring up a new remote PowerShell tab, we'll type in DC-nug, press enter. We'll give that a moment. Fantastic. I'll type in CD / just to give us a little more room, and a CLS. And then here with the DC-nug tab selected, let's go ahead and click on Open, or you can do File Open, that works too. And let's go ahead and double click on 18-HMM server, which is in the temp folder. And that's the document that we were just looking at in Notepad. Also, another option as you do this in the hands-on lab is to not open this document and just walk through it manually, putting the commands in using the Help As You Go system that PowerShell provides you. And because we just went through all of these commands, let's go ahead and launch them. I'm going to highlight row number 3 and press F8 to execute that. And dun, da, 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 we now have a brand new zone called HMM.com. It's a primary zone on our DC-nug server. Next, let's go ahead and add a couple of DNS server client subnets. That's row 5 and 6. We'll highlight row 5 and 6 and press F8 to execute those. So now we have our two subnets identified, the 64 subnet and the 128 subnet. Next, let's create two scopes, one that's going to be matched up with each of those subnets. But before we can match them up in the policy, we have to actually create the scopes. So with row 8 and 9 highlighted, we'll press F8 to create two new scopes, one called 64_ scope and the other starting with 128. Next, we'll create two A records, one in each scope, both as part of the HMM.com zone, and hit F8 to execute those. Then we'll scroll down just a little bit more. Next, we have the two policies, one that's looking for traffic coming from that 64 subnet, one's looking for the 128 subnet, and based on the matching of those, it'll go ahead and pull the result for server-XYZ. So with row 14 and 15 highlighted, we'll go ahead and press F8 to execute those. And ta-da! We're done. So let's go ahead and test this. To test this, let's go to our local Windows 10 client. We have a tab up here on the left for that. And let's go ahead and open up some commands I already have in the temp folder that can speed us along our way for testing this. So to do that, with the PowerShell 1 tab selected, we'll click on File, and let's go ahead and click on Open. Or you can just click on the icon for the little folder, which is a shortcut for Open. And here in the temp folder, I've got 18-HMM client. Let's go ahead and double click on that to open it up. So let's talk for a moment about what these are. Row number 1 is simply get-net IP address looking for Ethernet 1. And it's going to feed us the address family for IPv4. So that way we can see the details for our interface just to verify what the details are before we start making changes. Then we'll highlight the get-net IP address row and hit F8 to execute that. And let me bring this up just a little bit and scroll up a little bit more. So here's the command that was issued, and it's showing us that the current IP address is .120, which means this client is in subnet 64. So for subnet 64, that last octet range is 65 through 126. So currently the client's in subnet 64. Later when we change it, if we want to put this client in subnet 128, we'll simply go ahead and put it in 127 for the last octet through 190, anywhere in that range. It's also showing us the alias for that interface, which is Ethernet 1. That's the name, if you will, of that interface in Windows 10. If we want to clear the DNS client cache, we can. We aren't going to really need to, but if you want to, the command is there. That's row 3. Go ahead and use a squeegee to clear the output down below. And with row 3 highlighted here, we'll go ahead and press F8 to go ahead and clear the client cache. Next, we'll go to row 4 with the command resolve-DNS name with a dash name looking for srv-xyz.hmm.com. Now what's going to happen is, because we have the policy applied, it's going to look at our source IP address. It's going to see that we're coming from 64, and then it'll pull out that resource record out of the scope for subnet 64 and hand that back to the client. And that IP address was 22.22.22.22. So let's go ahead and try it. With row 4 highlighted, we'll press F8 to do the resolution. And what we should be able to do is hit F8 over and over and over and over and over. And because our source IP address is not changing, the server is consistently following that policy and handing out the IP address from the scope associated with our policy. So next, let's go ahead and clear the screen. I'll use the squeegee icon up here, and let's change our IP address. Now you can change the IP address in several ways. We could use PowerShell commands, we could use the older netsh commands, we could go to the GUI. And for this example, we're going to use netsh, and that's one of the reasons I also put us in as administrator, because we're going to need them to change the IP address. So with row 6 highlighted, we'll press F8, and we'll go ahead and change our IP address. So it didn't give us an error message. What we could do is do the get-net IP address command again. We could also use an ipconfig/all or an ipconfig. All those would be valid ways of verifying what our IP address is. So now that we made the change with row 7 highlighted, let's press F8 just to verify that. And we'll scroll up just a little bit, and sure enough, now we have the IP address of 192.168.1.129, and because 129 is in that range for the 128 subnet, now when we make DNS requests, when the policy is looking for our source address, it's going to think that we're in subnet 128, and it will respond with an A record from that appropriate scope, again based on our DNS policy. So let me go ahead and use the squeegee to clear off the bottom part here, and just for grins, we'll do clear-DNS client cache, highlighting that and pressing F8. And then we'll go ahead and do row 9 to resolve the DNS name again, the same as we did before, but now we should get the result of 33, etc., because it's being pulled from the scope based on the policy and where we're coming from. So with row 9 highlighted, we'll hit F8, and sure enough, there we go. I always get a little joy when things work like they should. It's fantastic. And we could hit F8 over and over and over again. It should always give us that result because our source address is coming from the 128 network. So if we change our IP address back, which is what row 11 will do for us, the netsh command setting it back to the IP address of .120, and with that highlighted, pressing F8, and then if we go right back and do row 9 again, the resolve-DNS name, now that our request is coming from the 64 subnet, based on our DNS policy, it's now handing out the IP address from the scope associated with that policy. So now, my friend, that we've gone through this together, I would encourage you, when you have a little bit of time, go ahead and launch the hands-on lab and then walk through it step by step. And if you want to watch this video again and you just pause and forward and pause and go forward as you do the hands-on, I've been told that's very helpful. Also, some people will have, like, for example, a mobile device like an iPad or a second computer or a second screen, where on one screen they can have the video to play and pause, and the other screen to do the hands-on practice. Whatever works best for you to help reinforce the learning that you're doing, that is great. And I appreciate you taking the time to do it. So have some fun with the lab, and I'll see you, my friend, in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.